Is being recorded. It will be posted with a link on the chapter website. Will be emailed after the fact, and we're going to take one out of the playbook of the Mid-Atlantic Coast chapter, who has now figured out a way to download these and post them up to a YouTube channel. So we're going to start doing that too. So we have a nice archive of our Lunch and Learn webinar presentations moving forward. So just a few updates before we turn it over to our guest speakers today. In terms of national updates, we do have a new executive director now for the organization. So Tony Pratt has now officially completely stepped down and has turned it over to Dr. Nicole Elko. So Nicole will be guiding the national organization into this kind of next period of growth and prosperity. And so far, she's doing a great job. She used the first few weeks of her position to reach out to and have direct conversations with pretty much all of the board members and all of the chapter presidents, including many others, and took that feedback, is kind of processing it now, and is going to use that to inform some important next steps. At the national level, the thing that the organization is working tirelessly on right now is coming up with a more healthy, balanced budget and a way to improve the budgeting predictability moving forward. Fortunately, one of the better impacts to the budget this year in terms of getting us back to square is that the turnout or response for the National Coastal Conference coming up in a few weeks in Providence, Rhode Island, has been absolutely overwhelming. ASBPA, whenever they have this rotation of the conference that moves around the country, they always get really excited when they host a conference in New Orleans when it comes to the Gulf Coast, because they know that the numbers are going to be large. And it's usually the Gulf Coast conferences are usually lead to the largest numbers. But the Providence conference so far may end up setting records. So I think there's well over 300 registered at this point, and then we will continue to get registrations up until the first day of the conference. So it stands to be a great meeting. The venue and location look amazing. The program looks great. So if you're on the fence about coming to Providence, Rhode Island, please hop on the fence and come on. So let's have a good conference up there and good representation from the Central Gulf Coast chapter. We have had this year some turnover in the board and the executive officers, and I just realized I'm missing. I was delinquent in putting somebody's name up here, but I'll just say it. In terms of board members, Kari Servold, who had been serving as our treasurer since the chapter was first chartered, has now taken over a position with the U.S. Army Corps of Engineers Mobile District. And so she is shifting out of the executive team and into the board of directors. And then also joining us from Army Corps of Engineers Engineer Research and Development Center are Amanda Trittinger, Brian McFall, and Sean McGill. And then from Neil Schaefer in Louisiana, Glenn Ledette. Then the person whose name I regrettably left off, I apologize, Peyton Posey with Moffitt Nickel is serving as a treasurer right now, and will continue to do so unless we overwhelm her completely. Announcements of the more immediate variety. We have a Lunch and Learn date scheduled for October 19th. The speaker is TBD, but that information will be delivered soon. We do have dates available in November and December. If anybody's got a presentation of a cool project they'd like to share, please reach out to me. If you are feeling so inclined, maybe in the end of this year or the beginning of next year, to step up and volunteer for the Central Gulf Coast chapter, please go ahead and scan that QR code. That'll take you to a series of, or a web page where you can pick from a series of different forms to sign up to get engaged with the Central Gulf Coast chapter in a few different ways. None of them, by the way, require much time or effort. We just need more people to spread out the effort. Nick Brown chimed in with a message to me that I'll read right now. Oral session for the National Coastal Conference set a record. Poster session set a record. Sponsorship set a record. So it's definitely going to be great. You're absolutely right, Nick. So with that, our announcements are now done. I think it's time to turn it over to our guest speakers, Tyler Ortego and Matthew Campbell. So I'm going to stop sharing, and we're going to kick this over to Tyler. And hopefully Tyler will be able to share his screen. And then we will get this going.
All right. Can y'all see my screen?
It's starting. It's thinking about it. Still black right now.
Still black. Let me try.
Maybe try a different window. Yeah.
Okay.
See a nice picture. It says Natrx.
Great. Can you see our Zoom stuff on there? Or is that hidden from me?
Nope. The Zoom stuff is hidden. You're good. We're just seeing the web browser.
All right. Perfect. Matt, did you want to say hello before I get rolling with the content?
Sure. Hello, everybody. I'll chime in around the Q&A period, but I was going to let Tyler kind of run with the presentation just to keep the flow. But yeah, I look forward to the discussion.
Thank you. All right. Well, thank you, Brett, for inviting me, and for everybody for showing up. I see a lot of familiar names in the participants list. Very, very happy y'all could be here. So I guess a lot of y'all know me over the years as the oyster reef guy, working on building coastal resilience via natural systems, and that's sort of grown and morphed over the years. And I guess most recently, I sort of coalesced into a company called Natrx. So we're bringing advanced technology for nature-based restoration and resilience. So we're going to kind of give you a bit of an overview there. So I'm one of the founding members. We started a few years ago, but I'm as of this summer, I'm back full time with the team. I'm our general manager of coastal solutions. So if we're in the coast, I'll be your guy, and we'll be working with you. My vision, if we're successful in what we're doing, our designs and the use of Natrx products are going to be like weeds sprouting up everywhere, and you let 1,000 flowers bloom, and all kinds of creativity. So I'm hoping to do enough today to kind of spark some, get some creativity going, and hopefully, keep a conversation together. And part of what I want is for folks like you. So if you're a local government person looking for projects, the engineers who are doing designs, and scientists studying, to be able to, if you have a problem to solve, and we might be there to have the tools to be able to at least have a look at that. So I'll kind of take y'all through a little bit of a history and an overview of where we're coming from, and how that technology layer adds onto that. And then we've got some case studies, or I like to call them a bunch of pretty pictures. And then I've got a section called Training the Engineer, where I'll talk about some of the nuts and bolts of working with our stuff. Let's see if I can operate this thing. All right. So our philosophy is to build technology that promotes harmonious balance between the natural and the built world. So we've got, as engineers, we may be really good at the built part. As resource managers, we may be really good at the natural part. There's a whole lot of effort and money and interest in bringing those things together right now. And there's a whole lot of, learning by experience happening as we're doing that. And so I'm hoping, that we can help you to kind of do that. there's a lot of things that the engineering and infrastructure community already knows how to do very well. So, there's a time and a place for on-site structural work and bulk materials like earth and rock and whatnot. There's pros and cons to that, and there's a time and a place. I think in the face of changing climate and really a rapidly changing world, that the things we already know how to do aren't necessarily going to get us where we need to be. So we're rethinking what's possible, and so our philosophy is always starting, working with the power of the natural systems, and build useful things that harmonize with the site-specific ecology. We have tools to help minimize material use and construction impacts and carbon footprint and all that fun stuff. And then also be able to reasonably plan for those dynamic natural responses that may come from that. So here's a kind of a history. Some of y'all may have seen this or something similar over the years, but Matt and I started back way back in the LSU days, working on applying the biology of oysters to engineering structures, and so that's sort of the kind of the roots of where we're coming from. And here's an example of our first reef in the Rockefeller Refuge, where we built a concrete skeleton, and the whole thing was encrusted by oysters in a short period of time. And the bottom right here, you can see how they held the line there, whereas that canal was receding in other areas. I've actually been back here. I went a couple of years ago on I guess it would be the 10-year anniversary, and I pulled a 9-inch oyster off of that reef, and didn't taste very good, but I got it down. So some advantages of the biogenic shoreline system. So one thing we always tried to do in applying these nature-based techniques was to look at the infrastructure business and do things in a way that scaled. So we went towards precast concrete. There's a multi-billion-dollar industry that's producing pipe and manhole risers and things like that. And so we wanted to build a product that the existing supply chains in our country could build with. And we've learned a lot over the years in applying that coastal engineering. We've got a lot of advantages. If you're in soft sediments, we have lower bearing pressure. One thing we saw after the record-setting hurricane seasons of the last couple of years is that these can be really resilient to big storms. So here's one on the Gulf Coast of kind of south central Louisiana. Here's some oyster break here. This is post, I think, Laura, and then just to the east of it, there was a kind of a 90s, early 2000s era rock breakwater installation, and just built using more classical coastal engineering guidelines. But when you have that taller structure, we had 10 times more material by weight, but also when that storm wave overtops it and then comes back out, it channelizes and kind of wreaks all kinds of havoc. So I think the case for nature-based infrastructure has been growing and growing. And, lots of other work in other areas as well. So this is where Natrx comes in. So we're sort of taking Matt and I's core work, and we're making it high tech. We're getting with the 21st century here. And we got two parts of that. We call the overall philosophy Nature OS, kind of our operating system. On the front half, the digital half, we have Nature Assess. We're using satellite tools, which we'll show a little bit more in a minute, to look at erosion patterns. Prioritize really is the essential element there, but also to monitor and document and quantify and all the things that we need to do to have better nature-based resilient solutions, but also to justify them and make the case for funding and whatnot. And then the second half of that is called Nature Address, where we have our patented manufacturing process to target those priority areas. Okay, so Nature Assess is satellite based. So we work with a company called planet.com, and we're able to generate monthly, nice resolution multispectral imagery. And we tie it in for a project, and we're using machine learning algorithms to look over that time series and identify the erosion hotspots. We're getting closer to having a predictive tool there. And then also on the back side of that, having it as a monitoring tool as well. And so here's kind of some examples of shoreline segmentation in our little boxing algorithm, which we use to segment the shoreline. All right, so the second half of that, I think this is really where we get into the project implementation. We call it nature address. We've got a process called dry forming, and dry forming gives us a rapid digital-based design tool, so we can go straight from the computer to our machine and come out with a product. Some of the highlights there are this sort of naturalistic look, complex geometry, which you can apply to different ecology and things like that. We can design them for different hydrodynamic purposes, so wave dissipation, current manipulation, sedimentation, etc. And some of the common uses, we've been getting a lot of traction with living shorelines, or in places where your permit requirements are pushing landowners away from bulkheads. We use them for fish reefs. We've done some stuff with beneficial use of dredge material. This is a schematic of how it all works. So we've got a box. I don't know if y'all can see my mouse moving around, but the core process is we have an array of needle that pushes down into a dry mix of Portland cement and some smaller aggregates. And our controller system on every vertical step turns those needles on or off and pumps water in there. You get these little diffusion balls, and where your diffusion balls line up or match up, you get your structure. It's, we can go from digital design and proofing to production. Our slide here says within 1 day, but almost in an hour, if we can get the approval done. And so what can you do with if you can do anything you want, right? So we're looking at coastal habitats and coral reefs, living shorelines. We worked with Moat Marine Lab on this little crab house. Looking forward to some data from there. This one on the bottom left, we call it the lattice. We've actually, we've got some in the water. We've got some where we filled the cavities with earth and planted pollinator flowers. Just having fun and hoping to spark some creativity. And since we're not mixing a slurry, we don't have workability constraints, so we've been able to do all kinds of different materials inside of our mix. We work with some low carbon binder providers to try it out. We've used contaminated sediments as a fine aggregate, and we were able to isolate those contaminants, calcine clays and dredge material to make a binder. And so the sky's the limit. Get to some case studies here. I guess a quick update. We're headquartered in Raleigh, North Carolina. We're in the process right now of moving our primary manufacturing capacity to Amelia, Louisiana. So we'll have a whole setup over here running, and hoping to be doing some show and tell soon. All right, so that's kind of the overview there. I'm gonna we don't have any questions. I'm gonna jump into some of the quick case studies, and then we'll do the engineer training, if that sounds good. All right, so mentioned earlier, one of our most common applications or easiest sells right now is living shoreline. So this one was a homeowner in Virginia. If you're on the Gulf Coast, you might not be used to an actual tidal range, but it actually goes in and out every day. They've got really sensitive and highly protected seagrass beds And so we were sort of working between the marsh and the seagrass. We were able to come up with a solution that fit in that slot there. We got the vertical elevation we needed. Install was super fast, so the contractor was able to float his barge in at high tide, and these pieces just go down quick. We work on our contractor customers about wearing hard hats when we take pictures, but here's one where we worked with the Coastal Conservation Association. We had one for North Carolina, another in Louisiana, where we built these big cubes with big cavities for fish to get comfortable in. Again, pretty easy install there. And then in this case, we had a sort of buoy based release mechanism, so they would drop these down on the seafloor and then hoist the straps back up. Got almost immediate fish utilization, which was pretty exciting. Looking forward to hearing some more about that, and some nice press if you want to go watch us on TV. Here's one where we had where our quick turnaround came in handy. So this was a permit. Matt, was this in North Carolina? Yeah, Havelock. There we go.
Yeah.
Well, we had a situation where it was getting really close to go time. Needed a narrow footprint for the permit, but the permitting agency also wanted some mass on that front structure. So we were Native Shorelines asked us to come up with a complement to their quick reef system. So we made this front-facing slope part with these notches on the back where their quick reef modules fit in. So we went from physical digital design to physical production in a week. And we cranked those out and we got them over to the job site. They were to install pretty quickly. Here's one where we had much deeper, steeper vertical profile. So we went with a stack solution. This guy here actually has a huge open fetch across Chesapeake Bay and actually opens up to the Atlantic. I don't know if the swells actually come in from that direction, but we're in a nice testing ground here for wave stability. And that's another one where working with between the natural shoreline slope and then seagrass beds just offshore of our alignment, and had to really dial in exactly how to get the right level of protection there. So here's one, you saw a picture of it earlier. It's called Hellhole Bayou. It's a real place. There's a pipeline here, oil and gas pipeline that comes through. This, down here at the bottom of the screen is Hellhole Bayou. And like every other coastal waterway in Louisiana, the shoreline is retreating. And what happened, this old bulkhead, which you can see kind of on the bottom left, near this energizing station here, water got up in the marsh, blew out around the bulkhead, made a big deep hole. All the couillons down the bayou coming in there with their boats. There was a risk of having a boat strike on a major Gulf of Mexico oil pipeline. So the idea here was that we wanted to plug to reduce the tidal exchange through this canal, which is not supposed to be there. But to avoid having just chasing that problem down the road. So the thought was if we just put a rock plug, eventually the next storm that water would set up and it would just blow out around the rock plug and move the problem, a couple dozen feet down the shoreline. And so we had this sort of a flow through weir here that's both serving as an ecological feature, but also as a kind of a pressure valve for that water exchange. I mentioned earlier we did a pilot study for the Maryland Port Administration where we mined dredge material and did some tests on that. It was a pretty fun project. I don't know if it'll move on to the next level or not, but we'll see how that goes. All right, so this is the fun part where we talk about how we get to work together. So I'm assuming in this case there's going to be a whole lot of um, folks who are interacting with public dollars in one way or another. So whether you're at the engineering firm or the local government, um, even even non-governmental organizations working with grant funding, kind of talking about this interaction here. So if you're in the business of building things, this shouldn't be too new for you. There's all sorts of manufactured products that go into infrastructure, but I feel like it's always kind of a question, and we need to make sure we understand each other. So I'm going to go into a little bit of the division of responsibility, how the different parties fit together. Offer a little bit on plan form, cross section, and exoform design, and how we can work with specifications to make sure that you get what you want, and some thoughts on construction. So first thing, okay, who does what and who owns what? So in every project there is an owner, right? The owner's got the money, sets the priorities and budgets, owns the permit, secures the land rights. Usually most cases, the engineer is going to work for the owner. The engineer represents the interests of the owner, but also has an ethical responsibility to uphold the interests of the public, life safety, and all that good stuff. So the engineer we're going to work with you guys and come up with some potential solutions. But at the end of the day, somebody's going to be the designer of record on this project. And somebody's going to go through a bid process that's going to select a contractor. Contractor also works directly with the owner. Contractor buys the materials from us, builds, comes up with their own means and methods and builds according to the bid documents. In this circumstance, our only contractual arrangement is going to be with the low bid contractor. And as many of the actual construction could be the last year of a multi-year process, right, between the designing and the permitting and trying to get the money to do the work. This could be a long thing. So we've got a partnership with the Danos family for fulfillment and delivery. My job is to work with you all, early on and throughout the process, to smooth that out, and make sure that by the time these things go to bid, that our risks are mitigated, that the use case of our product matches what it can actually do, and all of that. So I'm here for you, even if sometimes the paperwork may get a little strange. So on plan form design, this is really in your court much more than ours. So where are you going? We've got some tools to help you prioritize that, but in a lot of cases that's already determined. Besides our eye in the sky, you're going to get detailed survey information and geotechnical information. You may have, for like this one in Virginia, have seagrass that you have to dodge, or a utility or something like that. So what goes into good coastal engineering. So that's kind of just the basics there. Some things to think about in this case. This engineering team followed a contour, and they sort of weaved in and out of the known seagrass. They placed on the natural bottom most of the time. We're following a natural contour, though sometimes, like on the bottom right here, we followed a built contour. You might look at different segmentation arrangements to deal with the hydrodynamics. You might have different districts, different permitting requirements that come up. Cross section is kind of a little more shared, I guess. So if you're dealing with a wave breaking structure or a float structure, that cross section is going to be pretty important to your design. So I've got here some real cross sections from projects we've either won or proposed. And I've got this on the bottom left, kind of a classic diagram of wave transmission from the coastal engineering manual. So if you have, if you're designing a classical coastal structure, your wave attenuation is going to come from the vertical component, so the relative freeboard. The higher it is, the lower your overtopping. If you're designing a wall to keep ocean swells out of the Port of Long Beach, this thing's going to be massive. If you're designing you're protecting a marsh edge in a small bay, it's a different design philosophy. And I think there's a lot of good work in the last 5 years or so around how to look at that. Structure width plays a role in that. The porosity and how the waves pass through it. There's an allowable transmission. I think Brett's done some work on erosion of Spartina edges, things like that. So this goes back to the objectives and the needs and the goals of the project. So some cross sections here up above the diagram. We've got I guess kind of, this one was for a pipeline company, and it's almost more of a nature-based fence than a nature-based resilience measure, but they've had pipeline right away, they track equipment or whatever, and it starts becoming a waterway. They need to keep boaters out, prevent boat strikes, and so we're actually going to be crossing over on top of a pipeline with this guy in the fall. On the right hand side is the cross sections from the project I showed earlier. So we've got kind of two different areas of that. One is a more exposed and deeper section where we stacked our exoforms, and then the other on the back side of that island, they were still having some erosion, possibly from boat wakes, but it was a gentler slope. We're putting these 18-inch tall units right on the marsh edge, and then we can also go and multiples or whatever we need to address the wave climate for that site. All right, designing for the exoforms themselves. So this is probably the most in our court, based on the information from the prior two. But I think it would be good kind of have this out there, and we'll be working on some design materials to help get the job done. So our if you're looking at what does this exoform look like, it's it's one thing if a company has a product that has certain dimensions, and that's what it is, right? But with us, if you could fit it in that 3-foot box, we can do it for you. So your major dimensions probably is largely going to be driven by the vertical relief that you need. You may have weight considerations. You might need it to be light for light loading or soft soils. In my experience, if you get the vertical dimension from one of these, you're going to be several times heavier than you need for wave stability. We do need to make sure we have sufficient mass in that shape for structural integrity, and so that's sort of where we like to hang on to a little bit of that. If you want to design in specific habitat creatures, so we got our little crab friend on the bottom left. The bottom right, we got some with a lot of surface area for your benthic organisms. We've got fork pockets integrated and strap holes and whatever else. If you want some aesthetics, sky's the limit. One thing I'm working on that I'm pretty excited about, that I think is going to give us help really build some confidence in designs, as I'm working on a Flow 3D study where we're going to take some of our shapes and different configurations, and we're going to run them through a whole battery of wave and water level conditions and come up with as part of our design manual, we'll have some dimensionless plots or some equations, so you can actually apply that to your project and select the right crest elevation and width and all that good stuff. So that's coming together. There we go. All right. So specifying, if you're working with government money, this can get really really weird. I've seen different jurisdictions have the laws written differently. Sometimes sneaky people get state legislatures to do sneaky things. It seems like every agency, even in the same jurisdiction, might have their own interpretations of how that's supposed to work. You know, we'll figure it out. I think I've seen it all. So, you know, some ways that we could do that. Obviously, you got to comply with the law. You know, your agency or your client's probably going to have you know, general counsel who's gonna review that. Or you know, whatever you normally do if you have a product in a bid. One way to do that is just specify directly and have an or approved equal. Some folks will just go ahead and do that and say, yeah, you know, not going to approve anybody else. I've been on the good side and the bad side of that arrangement. We can work with you on performance-based specifications. So either looking at a module or a whole cross section, including other things like earthwork and plants and whatever, and base it on some hydrodynamic methods, you know, wave attenuation or something like that, and then use Flow 3D and other studies as part of the contractor submittal to get that done. You do the same thing with habitat metrics if you're looking at, you know, maybe surface area or cavity space or something like that as a criteria. And then that way you're not specifying a product, you're specifying what you want it to have. And then another way is geometric. So if you really like a particular shape, you know, we can specify that shape and come up with some descriptives of it, and then you know, somebody else could figure out how to make it. More power to them. On the construction side, we're almost always water-based construction down here. I guess there are circumstances where you know, you have convenient land access, but you know, we're frequently water-based. One thing with these concrete structures compared to rock is you run out of space on a barge before you run out of draft. And so we've been able to work in shallow water pretty consistently over the years with oyster break and with exoforms. And so, you know, the top right here, we've got a reef out in the Gulf of Mexico. You know, these guys spud it down and they were used long straps and they dropped down. They had a kind of a gravity release mechanism. Two pictures on the bottom left are one of those big 40-foot 4-engine airboats with a crane on it. And Danos modified a logger pick to grab the exofarms and set them in place. And then bottom right is Hellhole Bayou. And for that one, you know, the water was probably 6 or 8 feet deep, depending on the tides. And the pipeline operator, you know, has really stringent worker safety standards and said, look, if you're going far that far below, if a man's in the water, he has to be a diver. You know, insurance and all kinds of things goes through the roof. And so what we did was we built probably a 2.5 or 3 foot tall foundation out of smaller rock, and then leveled it out, and then built that flow through plug on top of that. So that is Natrx and our satellite tech and exoforms, and I hope you know, might have run through that a little quicker than I did in practice, but hopefully the Q&A keeps it lively.
Well, that was great. Thank you so much, Tyler. That was a great presentation in terms of content, organization, and also some really great pictures. That's really exciting product. We have a number of people, I guess about 30 or so participants on the line. Participants, if you got a question, you can either drop it in the chat or you can unmute yourself and ask it. But just remember, you are muted when you came into this meeting. So feel free to ask away.
I'm gonna start calling names.
Hey, Brett, this is Sean Powers. First, thanks for inviting me. I really appreciate you extending the invitation to the non-engineer, simple-minded ecologist in the group.
Hey, we all need to work together here, Sean.
Right.
There you go. There you go.
Want you on the team too.
Oh, yeah. Well, so I had a question about some of the reforms that you use and I mean, like everybody, I wish Alabama had the settlement that I used to see in intertidal North Carolina for oysters. It helps these structures a whole lot, not to have tons of oyster drills around. But secondly, Brett and I have been looking at a project, and they're using a lot, and Brett can give you the correct term, but crushed concrete. So what is the general cost differential, and why would you use the crushed riprap sometimes? Are these preformed things easier, cheaper? I would assume they're more expensive. Can you walk us through, the pros and cons of the riprap versus these prefabricated structures?
Yeah. All right. Where to start here? So I guess some of we'll talk about trade-offs, right? So if one, you could just describe something that we do on the other side, it's, kind of site specific, whether it's a pro or a con. If you're building with an aggregate material, whether it's a grain of sand or a boulder, you're going to have a natural angle of repose, and you're going to have a more suitable slope for your waves and whatever. So one way with a fabricated structure is you can have a tight footprint that achieves your vertical to get the same vertical. And then if you got soft sediments, we're always going to have a much lower load on that foundation. So that's part of the trade-off. As far as the final cost of installation, some of that's going to be kind of market driven and what's available and what the local contractor base is used to working with. We have seen with our exo farms that the placement is it's fast and easy. So the contractor could be in and out in a day. So that's probably one of the opportunities to perform on cost there.
So, but in general, are those prefab units generally much more expensive than the riprap? I mean, I know it sounds like you save money on deployment and you get better up to your specs, but I mean, is it, and I know, is it 7 times as expensive?
Well, I'll give you an example if that helps. Okay, so we had a project up in Virginia where it was a homeowner project actually, and they split the grant in half. So half of it they were doing traditional, you're saying riprap, but they were using rock. They're using granite rock.
What are we talking about? Brett knows what. Without the specifics.
Quarried stone. It most likely down here it's limestone, but it's quarried stone.
And so they split it in half. They did traditionally how they would do it with the quarried stone, and then the other half they did with ours. And we were able to do 3 times as much linear footage for the same price. And so that was all in cost of everything on the project. Now, if you're using recycled concrete and it's close to the site and it's a low wave energy environment, and someone's giving it to you for free, we're not going to compete with costs with that. But if it's a typical project where you've got a somewhat moderate to high wave energy environment, we typically compete very well in cost with a typical rock project. But I will say this too, more and more we're getting interest in our products because of the aesthetics, and I think people are wanting something that looks natural in the environment that they're in. So there's other benefits to that for some clients. Some just want the cheapest cost. If somebody gives them, a bunch of concrete rubble, they'll throw that out, no problem. But then there's other projects where, they want something a little higher quality.
No, and I agree that the aesthetics are unfortunately not factored in. I understand it's hard to monetize that, but on the performance, I mean, especially with things like oysters and everything, obviously you can do stuff with your mix. Do y'all generally find that y'all are getting better oyster settlement? And here I'm talking about oysters, oyster settlement than the quarried rock?
I don't think so. I mean, not the settlement. The materials, what I've found after doing this for about 20 years is the materials don't matter that much unless you're poisoning them with something. It's more the texture and the other aspects of the design that matter more for the long-term survival. And so we're doing a study right now with Duke University where we're putting different types of grooves in the surface texture. Those grooves of different sizes. And the hypothesis is if the oysters can settle in those grooves and get to a certain size, they have a much better chance of survival. And so I think those are the things that we're seeing that matter, and we kind of try to integrate into our designs.
Yeah, and that's what a lot of the Virginia work has shown, that it's all interstitial space that determines that early post-settlement, that early post-settlement survival. It just has a tremendous influence. So that's cool. All right, thanks.
Thank you.
Thanks, Sean, for the questions. Kind of on a related note, Tyler, you said something that caught my attention for the kind of the fuse plug example that you did for the oil and gas pipeline. You said that, you kind of would run out of deck space on the barge before you ran out of draft. And I guess that's probably something that, typically does not happen in traditional rock breakwater construction along the Gulf Coast, at least, because the deployment depths are relatively shallow. So, most of our projects now, the expenses are going up in terms of, the contractor's got to come in and dredge a flotation access channel to bring the barges in, because they are drafting so much more because that quarried stone weighs a whole lot more. So that's interesting, because it's, everyone's kind of struggling, even the regulatory agencies, they hate seeing the flotation access channels, and it is an additional cost to the project and the client.
Yeah, we've never dredged access in all the years. I don't think with Oyster Break, if we ever dredged it, it was it's probably just built into the project for something else.
All right, got a hand up. Go ahead, ask your question.
Hi, this is Gianmarco. I wanted to ask you about, you have shown how these structures actually work very well, protecting vegetation and helping oyster beds grow and so on. But I wanted to ask you about, access to the behind the structure by, turtles, maybe allowing passage of shrimps, maybe even alligators and seals. I mean, how do they work with fauna and not vegetation, in a sense?
Can you take that, Tyler?
Yeah, so obviously that's going to be I don't think I have a really good picture to communicate that. Well, maybe this one might be a good one. A lot of that obviously depends on the local ecosystem, right? Like we don't deal with too many seals around here, but I could see where that could be a thing. So I guess if there's an analog in Louisiana that I've seen, when you have really long linear structures of getting over several hundred feet, maybe, the regulators will require you to have gaps of a certain size to allow for fisheries access in and out. You could let smaller organisms through with holes in the design, and I think a low crested high porosity structure just as a category is probably pretty good about that. I think for us, usually a lot of the organisms of interest are pretty small, and they're utilizing the marsh edge, or even going into the marsh at high tide, and so they're going over and around, and they're not too obstructed by that. Haven't dealt with turtles. I think if you have the type of beach environment that's likely to have nesting turtles, you might not get permitted for something like this. I don't know if they're, I'm thinking of Chandler Sound or the islands or other places where you might have nesting turtles that, that might not be an option for you.
And Jan, I'd also say that we typically try to link up with the domain experts that know about these sensitive species. And so if there's something that is of concern, again, we don't have a fixed form product. It can change, and it can change with those concerns. So for turtles, for example, and I know there's been some concerns around these artificial structures in turtles, can they get caught in them and things like that? Well, then you can design it to accommodate those parameters, which a lot of folks like at NOAA have studied and have started to come up with ways of safely designing these types of structures. And so I think it would depend on the situation again, but hopefully the team would have someone that could help guide that kind of design.
All right, we've got a question from Peyton in the chat. How is the product typically delivered, say to the Gulf Coast, for example, rail or truck, or whatever means and methods you use? Is it typically the responsibility of the contractor to arrange delivery, or does Natrx provide delivery as part of the cost?
Yep. So on the Gulf Coast, we will be manufacturing at a waterfront facility, and so we've got the opportunity to go direct to barge. We can go into a truck. I think in most cases, direct to barge is going to be where the action is. We have shipped from Raleigh to Louisiana, and successfully won projects with that cost structure. And then I guess typically it will be on the contractor. We could arrange for delivery, especially if somebody were looking to maybe stockpile or do something like that. And then with our partnership with Danos, they're able to offer like a whole spectrum. So they could just, we could manufacture there, and the contractor bidder comes and picks it up, or Danos can load it for them. Danos can truck it. They can provide the barges. They can, bring it to site and not install it. They can bring it to site and install it. Kind of, there's a lot of flexibility there.
And we've also talked a lot about what are the economics around moving printers closer to the project sites. That's another option that we're always evaluating, and part of why we're moving something down to Louisiana now. But the idea is for us to have a distributed network of these printers so that we can service projects closer to the where the projects actually are, and we're going to move wherever the demand is and space for us to set up.
All right, Peyton says thanks.
You.
Last call. Any other takers? All right, hearing none, we'll close this out. I dropped something in the chat pod in case you didn't see it. Remember that whatever email you use to register for this webinar, I will email you a certificate for 1 hour of attendance that you can use for tracking, logging, and reporting your professional hours. If that's important to you, you're going to get one regardless, because I don't know if you want it or not, but that's what it looks like. And I'm also going to start sending the meeting invite card along with those, just for record keeping purposes. So it's going to show up in your email inbox later today. But if some of you have a viewing party at work and there's more than one person sitting with you, if they didn't register for the event, I didn't know that they attended, so they'll need to reach out to me directly, and I will send them their certificate. Just don't forget that when I send these, it does not have your name on it. So if you're going to use it for reporting purposes, make sure you add your name.
Thank
All
you all
right,
so much
everybody.
for having us, Brett.
Yeah, Tyler, Matthew, thank you both very much for doing this. This is really exciting stuff. I will just shamelessly say, whenever you all want to test these things in our wave flume, you're more than welcome to bring them over.
Cool.
Not that you need it,
Thank you.
but if you ever do, we or somebody else will surely help you there.
We should get some demo pieces over there, Matt, for the students.
Absolutely. Yeah, that'd be great. Well, thanks everybody so much. Stay tuned to email for updates. We'll send out the speaker info for the October Lunch and Learn. And if you've got a project you want to talk about, let us know so we can get you on a November, December date. Thanks, y'all.